Let's look at direct variation equations. These are lines that must go through the origin. Here's an example graphically of where you have a line going through 0, 0, which is the origin on a graph. And all linear equations can be written in this form, but when you're going through 0, 0, that means the y-intercept is a 0. So that means we have y equals mx. And for direct variation, we call the slope, or the number multiplying to the x, we call it k instead of x. It really means the same thing. But you want to get used to the format and the wording and things like the letters that are normally used by most people. And so we're going to call it k for now. Okay? So as an example, this one, let's say up to and over 1 or so, this one may be y equals 2x. So in this case, the k is 2, the constant number that doesn't change in the equation. You can put any x in there like 5. 5 times 2 is 10, and so you get a 10 for the y. Put a different number in for the x, and you're going to multiply by 2. The 2 won't change here. But what it does do is it changes the x, or rather makes for a different result. Okay, now let's look at what we'll do. I call this part 1 on here. And now what we're going to do, I'll call this part 2 here. Let's look at some information I'll give you, and we're going to write that equation. So we're going to say that y varies directly as x. Oops, let's write that so it's more readable, as x. Now, another way to think about this, by the way, is if it varies directly, that means when the x goes up, the y is going to go up also. If the x value goes down, the y value will also go down. This number multiplying to it will make it go up faster or slower, but it still will make it go, or, you know, it just changes that much. So here, if the x is 5, the y is not the same, but it's changed by the 2, it's 10. When I make it 6, 6 times 2 is 12. So this one's going up by 1 every time. Here it's going up also, but it's going up by 2 because of this multiplier. It's still going up though. And if the x were to go down, the y would go down. So that's what would happen here, and that's why it's directly. Directly means when one's going up, the other goes up. Anyway, let's come back to how we're going to make an equation here. Y varies directly as x. That tells you this, that you would be using this, or that you'd be thinking this way. Now I'm going to tell you that y is 15 when x is 9. That gives me some information to go into here. And I'm going to say, or ask you to do this. Write a direct variation equation. So that means I want to do y equals kx. But I didn't know what the k is. I don't know the k, but I do know one pair in xy. And think about what this is telling you. If the x is 9, the y is 15. Aha, I put it in that format. And you're used to sometimes using that format with equations, so let's plug them in. 15 equals k times 9. Divide by the 9, and I get 15 over 9 equals k. Let's reduce that. I think I can go 3 goes into that 5 times, and then 3 times for that. So I'm going to do, let's say 5 over 3. That means though, so let me do this. Let me say k equals 5 over 3. Cool. That's not the answer. I didn't ask you to tell me what k was. Did I say, tell me what k is? I did not. I said write a direct variation equation. So you have to put that back in here and say y equals 5 over 3 x. So that is a direct variation equation. This will get you only half credit, and I might be unhappy enough to not count as any credit at all, because you didn't actually do what I told you to do. You only did halfway. Well, halfway is halfway, so I might give you half credit. But you won't get full credit unless you actually do the whole thing. I want the equation. I don't want the k. I want the k inside the equation. Very important thing and very common mistake. I see this a lot where people go this far and they just don't do the one more step of putting it into it. And of course, you can't put 15 and 9 here, because that was only a one-time thing for that one point to help you get this. Because you have to set it up so that any x can be put in here, and then you can keep on working to, use it, and so on. All right, now, let's have you practice one, okay? I want you to practice this. I'm going to say that y varies directly as x. That's information you need to know. And then I'm going to tell you that y is 20 when x is 5. Write the direct variation equation. Pause the video and come back to it when you're done. I will start talking in 5 seconds on the video. Go ahead and do this first and then come back and see me do it. Okay, now we're back to it, and I'm going to see, same idea here. I want to do y equals kx. I have a y and an x, so I'll say 20 equals k times 5. When I divide both sides by 5, I get k is equal to 4. Great, but I need to actually put the 4 into the equation, and there I just did it. All right, y equals 4x. So now let's do this with a different thing. Here, I know it's 15 and 9 gives me 5 over 3 for the k, and it gives me that equation. 20 and 5 gives me a 4 for this, but I put it in the correct format for that. So now we're going to look at slightly different type of this. Part 3. This is still section 3, 4. Let's set this up for that on direct. Now I'm going to tell you y varies directly as x, and y equals 4 when x equals 6. Oh, good, I could make an equation with that. Now I know how. But here's what I'm going to ask you. What is y when x equals 20? Oh, I want to know that. There are 2 ways to do this. One of them, okay, 2 methods. One method is to use what we just did. Let's make an equation, y equals kx, because we know one pair that works for this particular direct variation equation. So we can put the 4 in here, and the 6 in here, and divide by the 6. And let's see, if I reduce these, divide them both by 2, I'm going to get 2 over 3. So I now get y equals 2 over 3x as an equation. Not the answer, because this didn't say what is the equation. It does say what is y when x is 20, and now I happen to have here something I can use. So think of this as part 1, and then think of this as part 2, where we substitute the 20 for the x. And now, 3 doesn't go into 20, but I can multiply here, y equals 40 over 3. And I can make that, so like that's the answer, because I can't divide. It would make a decimal if I do divide with a repeating number. And unless I tell you to approximate it, I'd rather have you keep it as a fraction. But this is an okay place to also say 3 goes in that 13 times at 1/3. So that is a good answer, or that is a good answer. Both of those would be acceptable. But you notice what I did is I used the first pair to make the equation, and then use the equation to get what it is when, what y is when x is 20. The other method, okay, so call this equation method. This is the equation method, if you want a name for it. And now let's try it with as a proportion method. For a proportion method, I can take this first pair and I can say like y over x. So I can say 4 over 6, but because these are on the same line, if the 4 compares to the 6 in that way, whatever the y is that I want compares to the x in the same way as really 2/3. So you see what I set up here is something where we can cross multiply. 4 over 6 is equal to something over 20 because they're in proportion. Another way this can sometimes be shown is that the y of the first pair over the x of the first pair is equal to y of the second pair over the x of the second pair. And if you put the numbers in, the one you're missing you can get by cross multiplying, which we're going to do in a moment, except I can't really do it without reducing here. I have to do my reducing because life's a lot easier to reduce, because now when I cross multiply, 3y equals 2 times 20, 3y equals 40, y is equal to 40 over 3. Oh, look, I get the same answers. Same answers. So both methods are perfectly fine. You can do it either way you want to. Doesn't matter one bit whatsoever, because as long as you get it correct, these are both good methods. Now, let's practice one. I'm going to say that y varies directly as x. And then I'm going to tell you that y equals 12 when x equals 8. But what I want to know is, what is y when x equals negative 36? Go ahead and take the next couple of minutes to do that yourself. You now have an example here of how to do it. The thing I just did, either method will work fine for you. Go ahead and do it yourself, and stop the video for a moment so you can do it all out, and then start it again. And I will pause here for 5 seconds and then start talking again about it. Okay, I'm back. And I guess I can try both methods here. So I'm going to do y equals kx. And I know the 12 and the 8, so I'm going to 12 equals k times 8, divide by 8. It looks to me like I can reduce these. K is equal to, let's see, 4 goes into that 3 times, and 4 goes into that 2 times. So k is 3 over 2, which means I have y equals 3 over 2x. Now there's a nice equation. I will now use the equation with that number. Y is equal to 3 over 2, and I'll put negative 36 in for y. 2 goes into 36 18 times. Okay. Am I right about that? 15, 16, 17, 18 times, yes. And then I can multiply the 3 times the 18. Oh, but there's a negative first. One positive and one negative. That's 30, 40, 54. So that means the y is negative 54 when the x is negative 36. So that would be the answer I want. If I do it the other method where I do a proportion, I'm going to do 12 over 8 is equal to y over negative 36. By the way, it's true, just back up here and here, if I were to switch these and do x1 over y1, that would be perfectly fine, as long as over here I did x2 over y2. You'd have to keep the consistency of the x's are, let's just say, horizontal with each other, on the same level. Now back to here, oh, I've got to make this, 4 goes into that 3 times and 2 times. Now I'll cross multiply. 2y equals 3 times negative 36. When I divide by 2, notice I didn't multiply that yet, because now I can do 2 just into this 1 and make it negative 18, and I'm going to get the same exact answer. So I'm correct one way or the other. And you're correct if you did this also. Now, let's look at this in a different way with a couple of word problems. All right, so what I'm going to do here is pull out this problem. A jet plane flies 4,000 miles in 20 hours. And write a direct variation equation that relates the number of hours and the number of miles. How far does the jet fly in 7 hours? How long does it take the jet to fly 5,400 miles? All right, given that information now, let's do it. We know how to make a direct variation equation. Y equals kx. We know this information, 4,000 miles in 20 hours. Part of our first job is to figure out what's the y and what's the x. So let's think about it in terms of what x and y stand for. The x is an independent variable, something that when you put it in, you do things to it and it changes to make something else. The other thing, the something else, is dependent on the x. So when you look here, normally we think about distance as that the number of miles you go depends upon how much time you take to do it, or how much gas you have in the vehicle, or whatever it might be. So usually we think of time as our independent thing, and that pushes something else to happen. So this should be dependent, and that should be independent. So if I were to put it into coordinate point form, I would be doing this. So I have an x and a y. So let's do 4,000 equals k times 20, and when I divide by 20, well, the zeros cancel here, and 2 goes into 400, 200 times. So it looks like k is equal to 200. So then the equation would be y equals 200x, because the 200 is the k. So now I have just done A. How far does the jet fly in 7 hours? The hours are x, and I could even put x here and y here to identify them more clearly. So that means for B, I need to just put a 7 in here. Y is equal to 200 times 7, and 200 times 7 is 1,400. Don't answer y equals, because there's no y in the question. Well, there might be somewhere in there in terms of the same number of miles, but you need to actually say 1,400 miles. So I'm going to say 1,400 miles. Okay. So that's the answer for that one. How long does it take the jet to fly 5,400 miles? So now we're given the number of miles, we need to find the hours. That means we're given the y and we're not given the x, but that means we can put that number in place of y. So I'll do 5,400 equals 200 times x. I'm going to do some lines here because this is where I worked out A, this is where I worked out B, here's where I'm working out C. Now when I divide by 200, okay, that all cancels here, and x is equal to, those cancel, 2 goes into 54. Let's see, 50 is 20 times, and 4 is twice, so 25 times, and then 2 more is 27. So that means it's 27. So that means it's 27 hours, because the x stands for hours. So I would come back up here, and then I would say 27 hours. Or I can say it down here, 1,400 miles, 27 hours. That's a long time to be on a plane. They better do some refueling and get you some fresh food there too. All right, so this is how you can use a direct variation, or make one and use it. There's another practice problem here to do. Let's have you try this practice problem. Because the word problems are ones that are often confusing for people. So let's just try one more and just get you better at it. Okay, here's this information. Read it through, then pause the video, and I will start talking in 5 minutes. No, 5 seconds. I don't even need that long. You just pause the video, take as long as you need, then come back to it, and you'll see me working it out. Go ahead now. All right, I'm back now, and let's look at this. I think we can do this in the same way as the others because we have a direct variation. Well, write a direct variation equation. So here's the numbers we need, the miles and hours. Again, I'll make this y and x. So I will say y equals kx, and this is where I'm going to work out A. And I'm going to say the number of miles is equal to k times the number of hours. And then when I divide by the 50, 0, 5 goes into 240 times. So 40 equals k. So that means that the equation, I'll put the 40 back in here, so y equals 40x is my equation. Now for B, when they stop on the 3rd night after driving 8 hours each day, how many miles have they traveled? Now I can use this, y equals 40x, And so I would put the number of hours here to find the number of miles. It's 8 hours per day. Just because you see an 8, don't put an 8 in there. They're making it, this question's making it really clear that they're stopping on the third night, and it even says each day. So that means they've gone 1 day, 2 day, and then they stop the third time, and it says each day was 8 hours. 8 times 3 is 24, so you need to use 24 for the X. Very important to pay attention to little things like that, and read it just as a normal thing. Think about, for some of these kinds of word problems, think about as if you were the one doing it. You travel 1 day, 8 hours, another day, 16 hours on the road, and another day, 24 hours we've been on the road. We're getting tired of this, but it emphasizes it's 24. And then you would multiply that together. Well, in that case, it's 960, and so it's 960 miles. So we're using the equation that we made up here to figure out the number of miles. And just like in the other problem, we're now going to do the opposite. In B, we were given the number of miles, and you could figure it out from the information. Now you're given the miles, this one, and you need to figure out this one. So we'll use the equation again. That's why making the equation is so helpful in many ways. You get two A's here. 2,800 is equal to 40x. Oops. That's not so easily seen when the lights go out. So let's get them back on. Okay. Let me move this back up where you can see better. If I divide by 40 here, so these cancel out. The zeros cancel out. 4 goes into 28 7 times, and then there's 0 here. So that means it takes 70 hours to travel 70 hours. So it takes 70 hours to go 2,800 miles. I'm going to come back up here and include those. So here, 70 hours for that one. And the miles they traveled were 960 miles. So now you see another way of, another example of a word problem, and then how to do it, where in both of those problems, and in almost everything you do with direct variation, first find the equation. Put it in the correct format so you can use it, but find the equation, and then use the equation based upon what's being asked. Your biggest job there is to pay close attention to whether you're working with the X or working with the Y. And if you focus on the way it's worded and what things match things, then you can do that. Here in this one, it went so far, and the last one, to tell you that the hours were to be X and that the miles were to be Y. That helps a lot. So it's really a paying close attention to the details that will help you on these kinds of problems. If you have any other questions about doing these types of problems, come on into Math Help. And hopefully this helps to understand this section well. Thank you.